In this video, we're diving deep into the world of quantum physics to explain the top 10 most fascinating quantum phenomena. From wave-particle duality to quantum entanglement, we're going to blow your mind. This is some weird science. At Unveil the Facts HQ, we take the hard concepts and break them down into understandable terms for all people. Get ready to enter the strange, out-of-this-world world that is quantum mechanics. You won't want to miss this exciting exploration into the realms of the most mysterious scientific findings. Let's begin. 1. Matter exists as both particle and wave. In 1906, J.J. Thomson won the Nobel Prize for showing that electrons are particles. In 1937, his son George won the same prize for showing that electrons are waves. Both were right. The phenomenon is now termed wave-particle duality and is a cornerstone in quantum physics. Sometimes the light is best understood as an electromagnetic wave, but at other times it's more useful to see it as a stream of photons. Like a giant light bucket, a telescope collects photons from distant stars, but it can also focus light waves from those stars and therefore exert pressure on an object. In fact, we are already using this phenomenon to launch spacecraft with solar sails, with the chairman of the B612 Foundation, Rusty Schweickart, even suggesting that we may be able to maneuver asteroids off collision courses with Earth. 2. Energy comes in multiples of quanta. The quantum world is like a shoe store. The relationship between the quantum world and shoes is similar to the relationship between the subatomic world and energy. Shoes don't come in sizes that match your feet exactly, so you have to choose between pairs that come in predetermined sizes. The same goes for energy. It only comes in multiples of the same quanta, hence the name quantum physics. Now, just like you have to settle for the nearest shoe size, particles also settle for specific energy levels. You can't have an energy level in between, it's either one quantum or the next. This is what makes quantum physics both strange and fascinating. Imagine a world where everything snaps into place like shoes, fitting only in preset sizes. 3. Something can exist in two dimensions at the same time. One of the most well-known theories about quantum physics is that objects can be in two places at once. This is known as superposition, first discovered in 1927 by physicist Erwin Schrödinger, and it suggests that an object's existence is spread out over time and space. This means that if you were to measure the position of an electron on one side of a barrier, it could actually be in two locations at once. The idea that an object can exist in multiple states at once seems like something out of science fiction, but is the basis of the famous Schrödinger's cat thought experiment. The fate of the cat is determined by a quantum device, illustrating how quantum mechanics is counterintuitive, and the cat can exist in two different states, dead and alive. 4. Stars are characterized by quantum physics. Danish physicist Niels Bohr showed us that electrons in atoms come in clusters like grapes on a vine, and these are called energy levels. When an electron jumps from a higher energy level to a lower energy level, it releases energy as light. Similarly, if you put more electrons into an atom at high energy levels, it absorbs light of those frequencies. Astronomers use this effect to identify the composition of distant stars. When we break up their light into a rainbow-like spectrum, we see colors that are missing, indicating the presence of specific chemical elements and allowing us to work out the constituents of stars, including what elements they contain, clues to their age, and other characteristics. 5. There is strong evidence pointing towards a possible multiverse. Quantum physics suggests that there may exist parallel universes where every possible outcome has already happened and continues to happen in some other universe. It also suggests that we could potentially travel between these parallel universes by manipulating the very fabric of space-time itself. An interpretation of quantum physics, the Copenhagen, states that observation collapses the wave function and forces reality to make a quantum choice. The many worlds interpretation argues that there isn't really a choice. Instead, at the moment of measurement, Reality splits into two versions in which we witness two different outcomes. Imagine a quantum particle as a ball being bounced between two mirrors. Every time the ball hits one of the mirrors, it bounces off in a different direction and continues bouncing for an infinite amount of time. Physicists call this phenomenon decoherence. 6. It is the basis behind why the sun shines. When you look up at the sun, you see the light that was created by nuclear fusion in its core. Nuclear fusion is the process of two protons coming together to create a larger particle. This larger particle can be anything from helium to heavier elements like carbon, oxygen, and iron. When these identical charges repel one another, which physicists term the Coulomb barrier, this causes them to give off light in a process called fluorescence, hence helping the sun shine. But this fusion process isn't easy. The protons need to overcome the immense Coulomb barrier before they can fuse, which only happens under extreme conditions like those found in the sun's core. Once fusion occurs, the energy released travels outward in the form of radiation, eventually reaching the surface. From there, it escapes into space, and after traveling 93 million miles, reaches Earth as the sunlight we see every day. The energy we receive from the sun is essential for life on our planet, powering ecosystems and driving the weather. 7. Stars don't really go away completely. The sun ultimately dies. Our star will collapse due to gravity, but not wholly. While becoming smaller, more and more particles are squeezed together. That's when Pauli's exclusion principle exerts itself, an important principle saying no two identical particles, such as electrons, are allowed to be in the same state in one and the same system. This therefore means that quantum physics does not permit any collapse of a star beyond a certain boundary, because it releases extra energy whenever gravity tries to crush it further down. Essentially, dead stars don't actually collapse into black holes as we might expect. Instead, it takes on the form of what we now know as a white dwarf. Over time, a white dwarf cools down and dims, eventually becoming a black dwarf, though the universe is not yet old enough for any to exist. The life cycle of stars like our sun is vastly different from larger stars, which may undergo a more dramatic collapse and form black holes or neutron stars. As the sun sheds its outer layers, these remnants will enrich the galaxy with elements like carbon and oxygen, fueling the creation of new stars and planets. In this way, the death of a star helps build the universe as we know it. So, while the sun's death is inevitable, it will also contribute to new life in the cosmos. 8. Black holes disappear over time. A Heisenberg uncertainty principle states that you can't fully know two properties of a system at the same time. For example, if you want to know exactly where something is in space, you can't know exactly how fast it's moving at that moment. In 1974, Stephen Hawking realized that black holes are not completely black, but emit radiation. This happens at a black hole's boundaries, where some particles escape while others are swallowed by the black hole. Eventually, the black hole will eventually evaporate as they are constantly shedding mass and energy. The emitted radiation, known as Hawking radiation, reveals fundamental insights into the nature of black holes and the laws of thermodynamics. This groundbreaking discovery not only challenges our understanding of gravity and quantum mechanics, but also suggests that black holes might not be the end of matter, but rather a complex process of transformation in the universe. 9. It accounts for the size of the universe. In the beginning, there was the Big Bang. Then in the 1980s, that theory was modified to include another theory, inflation. A new idea was formed that the universe grew rapidly before quantum fluctuations linked to the Heisenberg uncertainty principle had a chance to fade away. As a result, energy is concentrated in some areas rather than others, seeds around which material can gather to form the clusters of galaxies we are able to observe now. In fact, everything from galaxies to planets is all formed from quantum fluctuations in spacetime itself. These quantum fluctuations set the stage for cosmic structure, creating tiny density variations in the early universe. As the universe cooled and expanded, gravity acted on these variations, pulling matter together to form stars, galaxies, and larger structures. This process of cosmic evolution continues even today, with galaxies clustering together in massive superstructures. Without inflation and quantum fluctuations, the universe would likely be a more uniform, featureless place. The delicate balance between quantum physics and cosmic forces shaped the universe's complexity as we observe it now. 10. Things can get a little creepy. Quantum physics also has some strange implications for our everyday lives. These include weird effects like quantum entanglement, where two particles can be connected in such a way that they can affect each other, no matter how far apart they are, as well as quantum tunneling, a phenomenon where an object is able to pass through an energy barrier with faster-than-light communication. These bizarre phenomena allow particles separated by vast distances to be or remain connected at a quantum level. It's like an invisible force connecting them together, almost like magic. But the strangeness doesn't stop there. Quantum superposition is another phenomenon, where particles can exist in multiple states at once until they're observed. This principle is key to technologies like quantum computers, which harness this weirdness to perform complex calculations far beyond the capabilities of classical computers. Quantum cryptography, on the other hand, offers an unbreakable way to secure data by using the principles of quantum mechanics. These seemingly magical effects are not just theoretical, they're shaping the future of technology and science in ways we're only beginning to understand. Thank you for joining us as we explored the top 10 most interesting quantum phenomena. Hope you found these mind-blowing concepts somewhat as interesting as we did. If you enjoyed this video, please be sure to like and subscribe to Unveil the Facts HQ for more amazing science content. Let your thoughts be known in the comments section. The team here would love to know which of the quantum phenomena left you most amazed. Stay tuned for more exciting scientific discoveries until the next time, and keep asking the universe your questions.